Chapter 10.3 is areas of regular polygons, and the essential question is, how is the area of a regular polygon related to the distance from the center to a side? So we're talking about regular polygons, and we can circumscribe a circle about any regular polygon. So right here I have, what do I have? 6 sides, a hexagon. So I can circumscribe a circle around it. The center of the regular polygon is the center of the circumscribed circle. The radius of a regular polygon is the distance from the center to a vertex. So the radius is the blue dashed line. So it goes from the center all the way out to the edge, or to the circle. And the apothem is the perpendicular distance from the center to a side. So it goes from the center and then it goes to the side of the shape. All right. So the radius goes all the way out to the circle that would circumscribe it. The apothem is from the center to a side.
In this problem, you will find angle measures in a regular polygon. The figure at the right is a regular pentagon with radii and an apothem drawn. What is the measure of each numbered angle? First, find the measure of angle 1. Divide 360 by the number of sides. So the degree measure of angle 1 is 72. Next, find the measure of angle 2. The apothem bisects the vertex angle of the isosceles triangle formed by the radii. So use the measure of angle 1, a vertex angle, to find the measure of angle 2. How do you know the radii make isosceles triangles? Since the pentagon is a regular polygon, the radii are congruent. So, the triangle made by two adjacent radii and a side of the polygon is an isosceles triangle. Now substitute. So the degree measure of angle 2 is 36. Now find the measure of angle 3. The sum of the measures of the angles of a triangle is 180. Now substitute. The degree measure of angle 3 is 54. So, the degree measure of angle 1 is 72, the degree measure of angle 2 is 36, and the degree measure of angle 3 is 54.
Problem 1, got it. At the right, a portion of a regular octagon has radii and an apothem drawn. What is the measure of each numbered angle? So pretend this octagon continues on. They only drew half of it. So what is the measure of each numbered angle? So I would suggest, let's do the easy one first. Let's find the measure of angle 1. So the measure of angle 1, we know that total, it has to be 360 degrees. And since this is an octagon, there are 8 sides, and so if we divide that by 8, that will give us 45. So the measure of angle 1 is 45 degrees. Now, to find the measure of angle 2, we can take, it's just half of angle 1. So it's 1/2 of angle 1, which is 45. And that will give us 22.5. Now, for measure of angle 3, we know that for a triangle, it has to be 180 degrees. So we already have a 90-degree angle. We know that angle 2 is 22.5, so we're looking for this spot right here. So 90 plus 22.5 plus the third angle has to equal 180. So let's just write that out. 90 plus 22.5 plus this angle, we'll call it x, is 180. So if we do the math, measure of angle 3 must be 67.5 degrees. All right, the next postulate is 10.1, and it says if two figures are congruent, then their areas are equal. All right, suppose we have a regular n-gon with side S. So the radii divide the figure into n congruent isosceles triangles. So here's an isosceles triangle. By postulate 10.1, the area of the isosceles triangles are equal. So this one is equal to this, which is equal to this. Each triangle has the height of A and the base length of S. So the area of each triangle is 1/2 A times S, which makes sense because area of a triangle is 1/2 base times height. Since there are n congruent triangles, however many there are, the area of the n-gon is area equals n times 1/2 A times S. The perimeter P of the n-gon is the number of sides times the length of a side, or ns. By substitution, the area can be expressed as area equals 1/2 AP. So, to summarize this, we have the area is equal to the number of sides times 1/2 the apothem and a side. Well, we know that the perimeter is n times s, and the number times the sides. So let's just take this and this and replace it with a p. And that's how we got the equation. Area equals 1/2 of the apothem and the perimeter.
In this problem, you will find the area of a regular polygon. What is the area of the regular decagon at the right? What do you know about the regular decagon? A decagon has 10 sides, so n equals 10. From the diagram, you know that the apothem, A, is 12 3/10 inches, and the side length, S, is 8 inches. Step 1. Find the perimeter of the regular decagon. Use the formula for the perimeter of an n-gon. Substitute 10 for n and 8 for s. Now multiply. So the perimeter of the regular decagon is 80 inches. Step 2. Find the area of the regular decagon. Use the formula for the area of a regular polygon. Substitute 12 3/10 for A and 80 for P. Now multiply. The regular decagon has an area of 492 square inches.
Problem 2, got it? What is the area of a regular pentagon with an 8 centimeter apothem and 11.6 centimeter sides? So first, we need to know what the perimeter is. And the perimeter is just the number of sides times the side length. So the perimeter is the number of side lengths times the side. It's a pentagon, so we have 5 sides, and each side is 11.6. If we multiply those together, we get 58. So the perimeter is 58. Then we can find the area using our formula. The area is equal to 1/2 the apothem times the perimeter. We have 1/2. The apothem is 8, and the perimeter is 58. If we multiply those together, we have 232, and our units is centimeters squared.
In this problem, you will use special triangles to find the area of a regular polygon. A honeycomb is made up of regular hexagonal cells. The length of a side of a cell is 3 millimeters. What is the area of a cell? What do you know? You know the length of a side, which you can use to find the perimeter. What do you need? You need the apothem. What's your plan? Draw a diagram to help you find the apothem. Then use the area formula for a regular polygon. Draw a regular hexagon. The length of each side is 3 millimeters. Next, draw the apothem and label it A. Step 1. Find the apothem. Draw the radii. To find the measure of each central angle formed by the radii, divide 360 by the number of sides of the polygon. So the measure of each central angle is 360 divided by 6, or 60 degrees. Also, the apothem bisects one of the central angles into two 30-degree angles. The radii form 6 60-degree angles at the center, so you can use a 30, 60, 90 triangle to find the apothem. The apothem bisects the side of the hexagon, so the shorter leg of the right triangle is 1 1/2 millimeters. Substitute A for the length of the longer leg and 1 1/2 for the length of the shorter leg. So the apothem is 1 1/2 times the square root of 3 millimeters. Step 2. Now find the perimeter. Use the formula for the perimeter of an n-gon. Substitute 6 for n and 3 for s. Then simplify. So the perimeter of the hexagon is 18 millimeters. Step 3. Find the area. Use the formula for the area of a regular polygon. Substitute 1 1/2 times the square root of 3 for A and 18 for P. Use the calculator to simplify the expression. The area is about 23 square millimeters.
Problem 3, got it. The side of a regular hexagon is 16 feet. What is the area of the hexagon? Round your answer to the nearest square foot. So let's take a look at what we need to figure out. It says that the side is 16 feet, and we are dealing with a hexagon, so there are 6 different sides. So here we have a hexagon, side of 16 feet. We need to first find the perimeter. So to find the perimeter, we just simply take number of sides times the side length. We have 6 sides, the side length of 16. So our perimeter is 96 feet. We also need to find the apothem. We don't know what that is yet. I do see that I have a 30, 60, 90 triangle. So 30, 60, 90. This side right here is 8 feet, and the short side to the long side is the short leg times the square root of 3. So our apothem is going to be 8 times the square root of 3. So let's go ahead and plug that into our formula for finding the area. So if area equals 1/2 of the apothem, which is 8 times the square root of 3, times the perimeter, which is 96. And if we do the math, it's 665.107, and they want it to the nearest foot, so it's about 665 feet squared.